Today's aim is that students will be able to compare the constant of proportionality in tables and equations. Let's look at some vocabulary and key points to start with. A proportional relationship between two quantities is one in which the two quantities vary or change directly with one another. If one item is doubled, the other related item is also doubled. Because of this, it is also called a direct variation. The equations of such relationships are always in the form y equals mx, and when graphed, produce a straight line that passes through the origin. In this equation, m is the slope of the line and is also called the unit rate, the rate of change, or the constant of proportionality of the function. So let's look at some examples using tables today. Heidi is making cookies for an upcoming bake sale. Heidi recorded the number of bags B, I want to always underline any variables, of cookies C she would need to make in the table shown below. So she's making cookies, she's going to put them in bags, and here are the total number of cookies that she makes. Part A, how many cookies does Heidi put in each bag? Well, I see some keywords here. My question is how many cookies? I see the keyword each and bag. So I know whenever I see the word each, I'm probably looking for a unit rate. So I'm going to need something per something. We'll ask cookies first, so that's going to be first. Well, it gives me lots of information in my table, and I can pick any of these. I'll just use the first one to make it easy. So I have 119 cookies per 17 bags. I want to put my information that's given in the same order as the question. Now it wants to know how many cookies does she put in each bag. Remember, there's an invisible one here, each one bag. So I'm going to need to divide. 119 cookies per 17 bags is the same as 119 divided by 17, or I could rewrite it as 119 divided by 17. Be really careful how you transfer this. I've seen a lot of people switch these by mistake. Now, how many times does 17 go into 119? Well, if I think about it for a little while, I know it goes in 7 times. 7 times 17 is 119, and I have no remainder. So that means that Heidi puts 7 cookies in each bag. Now, I could write each one bag, but that's implied. So I've now found my unit rate, 7 cookies in each bag. Now it asks me to write an equation to represent the relationship between B and C. So I write an equation between my bags and my cookies. Well, I know in order to go from bags to cookies, I multiply by 7. So 17 times 7 gives me 119. And 19 times 7 gives me 133. And so on and so forth. You always multiply by 7 in order to get the number of cookies. So if I write that, I could think about bags of cookies times 7 equals the number of cookies. But we don't usually write equations that way. The way we want to write this is to use the variables. So instead of bags times 7, I would write B times 7 equals C. B times 7 equals C. And we want to put it, remember, in the form of y equals mx. M is going to be our unit rate. So I'll write my y in this case is C. So I have C equals 7 times B. So here's my equation. The number of cookies equals 7, there's invisible times, the number of bags. My final part asks me to complete the following table for other amounts of cookies if Heidi continues baking at the same rate. So still putting 7 cookies in each bag. If she made 16 bags, how many cookies would she make? Well, if we remember up here, all we did was multiply each of these by 7 in order to get to the total number of cookies. Just doing the opposite of the division here. So all I need to do is multiply. 16 times 7. 6 times 7 is 42. 1 times 7 is 7, plus 4 is 11, so 112 cookies. And then if I do that again, 18 times 7. 8 times 7 is 56. 1 times 7 is 7. Plus 5 is 12. So 126. And last one is 20. So I have 20 times 7, because remember I do bags times the 7 gives me number of cookies. 0 times 7 is 0. 2 times 7 is 4, so 140. And now it's time for you to practice.